Now friends, now in this video I am going to explain what is a random variable. In that random variable there are two types, discrete random variable and continuous random variable. With an examples I am going to explain them, differentiate them, and then probability distribution we will discuss one by one. Random variable means what then? If a real variable is associated with every outcome of a random experiment, then it is called as a random variable or stochastic or a chance variable. If a real number is, we are providing one real number to the every outcome of a random experiment, then such naming is known as a random variable. For example, or that is also in mathematical I will define. If a random variable is a function that assigns a real number to every element of a sample space of a random experiment. That is, x is a function from S to a R, where S is the sample space and x is we call it as a function. X is nothing but your random variable, is giving one real number. Okay, then such set is known as a random variable. A set of all real numbers of a random experiment x is known as a range of x. With an example I would like to explain this random variable. Suppose a coin is tossed thrice, 3 times, and let x and y be a random variables associated to the number of heads and number of tails respectively. X represents the number of heads and y represents the number of tails. Then whenever you toss 3 coins, there are totally 8 possible outcomes are there. Those are, that set is known as a sample space. In the last video I have explained that how it is. Okay, now whenever 3 coin is tossed, first toss, second toss, third toss, all 3 may be head. Like that, first 2 toss may be head and third toss may be tail. Like that, these are the all possible outcomes. That is head, tail, head, tail, head, tail, head, tail, head, tail, tail, head, tail, and all the 3 may become as a tail. For each element of a sample space, I am initiating or assigning one real number known as x as a number of heads on this. Therefore, total number of heads here is 3. I am initiating this one as a 3. Like that, in a second possible outcome, that is in a sample space, number of heads are 2. Number of heads are 2. Here also number of heads are 2. Number of heads is 1 here. Number of head is 1, number of head is 1, no heads are here, therefore 0. Therefore, x is taking the values from, it may take the values 0, it may take 1, it may take 2, it may take, or 3 it may take. Therefore, the set of all possible values of x is known as a range of x. Like that, I may define number of tails also. Correct? Here no tails is there, 0 number of tails. Therefore I am initiating, giving it, assigning it to a 0 number. 1 tail, 1. Number of tails is 1, whereas here number of tails is 2. Like that, 2, and 3 tails are there. The range of y is also 0, 1, 2, 3. Therefore this is known as x and y are known as random variables now. Okay, these are known as random variables. Further, in this random variables there are 2 types, discrete and continuous. While assigning these numbers, here step by step values I am giving, 0, 1, 2, 3, like that I am giving, or whole number I am giving. Such distributions, such a random variable is known as a discrete random variable. If these numbers are given to that particular sample or sample, that is known as continuous random variable. If you are giving 1.1, 1.2, 1.3 in a range from the limit, if I am giving, such are known as a continuous random variable. Let me define them. If a random variable takes a finite or a step-by-step countably infinite numbers, step by step, 0, 1, 2, 3, step by step they are taking, and that is a sequence of real numbers, then that is called as a discrete random variable. Okay, like that. For example, I can give tossing of a coin, all those things. Okay, whereas a continuous random variable, if a random variable takes a non-countably infinite number of values within that limit, given limit or a given interval, then it is called as continuous random variable. For example, lifespan of a bulb. Okay, it may range from 5,000 hours to 10,000 hours. That hours may be in terms of points also, 5.5, 5 point like that. Such things are known as continuous random variables. Okay, after that, this is a definition of random variable. How to use that random variable? Using that random variable, I am going to discuss about the discrete probability distribution. Before defining the discrete probability distribution, probability function I have to define. If for each value xi of a discrete random variable x, xi values, if capital X is a random variable, in that each element is known as a xi. If we assign one real number to that real number known as p of xi, such that condition should hold good, each p of xi must be greater than or equal to 0, and sum of all p of xi's must be equal to 1. Then that function p of xi is known as a probability function. This p of xi is known as probability function. And the set of values, all the values, okay, xi values for particular example 0, 1, 2, 3 and corresponding p of xi's all together is known as a probability distribution. And here the function p of x is known as a probability density function. If x is a discrete one, if capital X is a discrete random variable, then such functions are known as a probability density function. Then cumulative distribution function, f of x, or I will call it as f of t. F of t is nothing but a probability of x less than or equal to t. Up to t, whatever the probability functions, if you are adding them up to t, xi equal to 0 to 1 to up to t, all the probability addition is known as a cumulative distribution function. Okay, and the probability of x greater than or equal to t is less than or equal to t. Then how to find greater than or equal to t? That is given by 1 minus probability of x less than or equal to t. Okay, or if you want to find out probability of x greater than or equal to t, I can make it as 1 minus probability of x less than t. That will give you probability. Okay, with an example I would like to explain this probability function and probability distribution, as well as how to find the cumulative distributions. And important thing is probability function or probability distribution. Why we have to find out the distribution and all those things? Using this distribution and all those things, my intention is to find out the mean of that x and variance, how it distribution is varying. I would like to find out variance and its standard deviation. I will define those two first, then I will come back to how to define the function, and with an example I will explain one by one. First I will give you the idea of a frequency distribution. Say for example, in a class 10 students are there and their marks is given by like this: 35 for student, 45, 55, 60, and then 35 again, next 35, one more student, 60, 60, 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, one more student I will take as a 50. This is the total number. 10 students are there, and their marks has been given here. Then how to fit a frequency for that distribution for them? Here I will define a variable x as a marks. This is your variable, real variable, and corresponding frequency, that is nothing but number of students. Number of students will become your frequency. The marks is ranging from 35 to 60 maximum. Okay, 35. How many students are there getting 35? 1, 2, 3. Total number is 3 students are taking 3. That is known as your frequency. For 35, it is frequency is, that's why it is variable and its frequency is 3. Like that, 45 next. 45 getting student is only 1. Then 55. How many students have got 55 marks? That is also 1. Whereas 60 getting students are 1, 2, 3 and 4. Sorry, before that 50 I will make here first. That is also 1 student. Then 55 is also 1 student. Then 60, 4 students are there. Therefore, total number of students is nothing but 10. This is the marks. For these, I am finding the mean. How to find out mean from this we know already. Mean x bar is equal to summation of x into f divided by summation of f will give you mean. Like that, variance v is equal to summation of x minus x bar into f divided by summation of f, or one more square or one more formula, summation of x square into f, summation of x square into f divided by summation of f minus x bar square is also formula for variance. And standard deviation is nothing but sigma equal to square root of v. We know them. Okay, this is a frequency distribution, how to find out. Same thing I would like to discuss in the form of probability distribution. Okay, while defining the probability distribution, mean and variance of a probability distribution is given by, for a discrete probability distribution, mean is equal to summation of xi into p of xi divided by summation of p of xi will come divided by summation of p of xi. But summation of p of xi is equal to 1 according to the definition of probability function. Therefore, this is nothing but summation of xi into p of xi only, mean. Similarly, for variance also the same thing. Divided by summation of xi will come summation of p of xi, but that is equal to 1. That's why xi minus mu the whole square into p of xi, summation of x square into p of xi minus mu square. Therefore, standard deviation is also given by same thing. All these things I would like to explain with one example. Okay, one by one I will explain. Here I would like to explain that one in the next video. Okay, please go through that next video and please subscribe my channel.